Hello everyone. Today I'm going to discuss the last problem of Leetcode Weekly contest 443, which is minimum operations to make elements within key subarrays equal. So what is the problem? We are given an integer array nums and two integers x and k. So what we can do in one operation, we can increase or decrease any element of nums by one. Okay. So we have to return the minimum number of operations needed to have at least k non-overlapping subarrays of size exactly x in nums, where all elements within each subarray are equal. So let's take the first example. So here x equals to 3 and k equals to 2. That means that we have to make at least two subarrays of size x equals to 3 equal. So according, you can see that we can take the let me take this example only and let me write it here. Okay. So what we can do, we can choose these three elements. Okay, let me take another color. So we can choose these three elements, minus 2, 1 and 3. Let's say this is our first subarray, minus 2, 1 and 3. Increase this by 3 and decrease this by 2. Okay, then total number of operation will be 5 and our array will be 1, 1 and 1. Okay, and another operation, let me check what is that. Another operation is 5 and 6, 0, 1, 2, 3, 4, 5 and 6, 3, 6, 4. Okay, 3, 6, 4. Let's say we have another subarray 3, 6, 4. We can increase this by 1 and decrease this by 2. Okay, then our array will become 4, 4, 4, and the total number of operation here will be 3. So total number of operations for these two subarrays will be 5 plus 3, which is 8. So our answer will be 8 here. So 5 operations in this subarray and 3 operations in this subarray. I hope you get it. So we are taking these two subarrays. Okay, we have to take two non-overlapping subarrays. Now there are two parts of this problem. Okay, first find let's have a look at the constants. If what is the brute force solution? Brute force solution will be to check what is the like, there is no brute force solution. I mean, I can't really think of a brute force solution now. Let me discuss the optimal solution to you only. Okay, so there is two parts of the problem. That's what I am discussing. Is that what we have to find? We have to find the sum of all the, to make all the elements equal for a particular subarray. That is the first problem. Okay, so our problem one will be to find let's say we have chosen a subarray, and we have to find the sum to make all the elements, the number of operations to make all the elements equal. So this is a common problem. Okay, so for that problem, what we have to do, let's say we have something like x1, x2 till x3. Okay, so what is the optimal way to make all this element equal, and what is that element? The equal element. The equal element is nothing but the median of these three. Okay, so this the median of these three. Let's say x1 less than equals to x2 and less than equals to x3, then the median will be x2, right? Then we can make x1 equals to x2 and x3 equals to x2. That is the most optimal way. You can search about this. This is a common problem statement, that when we have to make all the elements of an array equal, what we can do, we can make all that element equals to the median of the array. Okay, so what we can do, we can find the median of the array of size x. Okay, median of the size x. Okay, but here you can see that x is of size num string. So at first, after looking at the constants, I thought k less than equals to 15, and I missed this. I thought that x is also less than equals to 15. So I tried to compute the median of an array. How we can compute the median of an array? We can take the array, sort that, and take the middle element of the array. That is the median. Okay, but here we can't really do that, because our like, we have to take from starting at I, we have to take the median of the array I plus x. Okay, let's call that median of the array, let's call it median I. Okay, let's say median I is nothing but start the array starting at I till I plus x. The median of that array is nothing but our median I. Okay, then this is a solution, but here x is length of the array itself. So this is not an optimal way to solve this, because we are solving this problem in order of n square. Okay, because we are iterating over n subarrays, and for each subarray we are computing median. So order of n square log n around. Okay, n square log n, you can say. This is not the optimal way. Now here comes another important problem here, which is a sub problem of this, which is called sliding window median. Okay, sliding window median, and this is a common Leetcode problem, sliding window median. So what does this problem say? We have to find the median of every sliding window of size k. we have to find the median of every sliding window of size k. So this is the problem, sliding window median. This is a very common problem. This is a hard category problem. So I will discuss this how to approach this problem. We can solve the sliding window median problem in order of n log k. Okay, we can solve the sliding window median problem in n log k, where n is the length of the array and k is the length of the sliding window. Okay, so how we can do this? Okay, let's say we have some array like 1 5 2 3 6 8. Okay, like that, and we have to take sliding window of size 3. Okay, so we will maintain two sets, right? We will maintain two sets, one let's say called top and another let's say called bottom. Okay, so what does it do? Like top means that it will contain the high elements, okay, maximum elements, and bottom will contain lower elements. Okay, so when we get one element 1, we'll put that into the bottom element. Okay, now let's say when we get 5, we'll add that, we'll check that if the size of the bottom, let's say we have sliding window of size 3. Okay, sliding window of size 3, then two elements will be in bottom and one element will be in top. One element will be in top. So we will add 5 in the bottom. Okay, we'll add 5 in the bottom. Okay, now when we get to 2, we'll try to add 2 in the bottom. Okay, but we'll check that the size of the size of this set bottom exceeds the 2, exceeds the value of 2, because we can have only 2 values in the bottom. So we'll remove this 5 from 2, 5 from bottom, and add 2 here, and add this 5 in the top. Okay, and at any moment of time, the maximum value in the bottom will be our median. Okay, maximum value in the bottom is our median. But you can see here in the sliding window median problem, if the sliding window has size even, then they are taking the average of the top 2 values. Okay, median 2 values, but here we can take any of the 2 values. Let's say we have something like 1 2 3 4. Now in this problem, sliding window median, they are taking the average of 2 and 3, which is 2.5. but in this problem we can really take 2 or we can really take 3. That does not matter. Okay, I hope you get it. So that is the overall approach to solve this. Okay, top and bottom. Okay, now this is to finding the median. Okay, now how we'll extend this to find the sum of the array to reach all the elements to median. Okay, so what we can say is that from all the top elements we are decreasing the value. Okay, so let's say there are k top elements. So the sum of the top, let's say that call at top sum or right sum, you can say right and left, you can also say. I have used that terminology in my code. Top sum means that sum of the top elements. Okay, so top sum minus length of the top. Okay, length of the top into median. Okay, length of the top into median. Okay, this will be required to make all the element of top to reach median. Okay, top sum minus top into median. And another thing will be like for bottom, the same equation will be bottom sum, sorry, let me say this will be bottom into median minus bottom sum. Okay, let me call it BS. So this is the total number of operations. For top, the operations will be top sum minus length of the top into median, and bottom for bottom, which will be bottom into median, length of the bottom into median minus bottom sum. Okay, that is the number of operations to make all the elements of the given sliding window equals to median. Total number of operations. I hope you get it. So this is a part of the problem. I have explained one part of the problem is how we are going to get offside. Okay, I have explained offside. Offside means that is that let me write it here. Offside means total number of operations. Total operations to make all elements from I to I plus x equal. So what we can do, we can take the sliding window and we can get the value of offside easily. Okay, I'll explain it in the code again. Okay, now let me jump to the second part of the problem, how we are going to solve for the entire array. So for that we can use recursion. Okay, so what will be my recursion parameters? One parameter will be the index and another parameter will be the number of subarrays. Let's call it sub. Okay, Now, this recursion is pretty straightforward. The main part of the problem is to find the sum of the sliding window. Okay, from I comma sub, what we can do? Let's say we have something like I comma sub. So let's say we are taking a sliding window starting at I. Okay, we are taking a sliding window starting at I. Then what we can do? We can take I plus x. We can go to I plus x, and we are incrementing the value of subarrays. Okay, I plus x comma sub plus 1, but we have to add the operations of I here, because we are taking a sliding window starting at index I. So this is one possibility, I plus x comma sub plus 1 and of psi. Another thing is that we can ignore this current index, so we can go to I plus 1 comma sub. This is the two recursion states, okay, recursion transitions, you can say. Now how we can make what will be our base cases? Okay, the base cases will be when I reaches n. If I reaches I greater than equals to n, then we will say that if the sub is greater than equals to k, that means we have reached we have reached k equals subarrays, then we can return. If sub greater than equals to k, then we can return 0, otherwise we can return positive infinity. Okay, we can return infinity. Okay, I hope you get it. So let's jump into the code, we'll understand it better. This is the part where I am calculating median. I am not going to explain because this is very hard to explain, like how I have explained the idea. You can search about sliding window median here, like how I am maintaining the left and right, and the left sum and right sum. I have already explained what it is exactly here. You can try to read the part of the code. I will attach the code in the description box. So let me skip this part. You can read it, and this is the part of the recursion. Okay, so if I greater than equals to n, everything I have explained. If I greater than equals to n, we'll just return 0, otherwise we'll return positive infinity. Okay, now there are two recursion state. We are going for I plus x sub plus 1 plus of psi, and we are going I plus 1 comma sub. Okay, this part is for initialization. So if I plus x greater than equals to n, that means there is greater than n. This means that there is no sliding window starting from I, so we can mark of psi as infinity. Otherwise, of psi will be our median j. Okay, I hope you get it. So this problem is quite interesting. If you solve the sliding window problem at first, then this might be a known solution to you. Otherwise, it might be very difficult. I have solved this sliding window median problem previously, so that is easy to me currently. The rest of the recursion and DP is quite straightforward. I will attach the code in the description box for your reference. If you have any doubt in any part of the code or explanation, you can always ask in the comment section. I'll try to reply each and every comment. If you find this video helpful, please like the video, subscribe to the channel, and also share among your peers. Thank you.